Quick example that demonstrates matrices. What you're going to do is you should go to this website here, mathsisfun.com/algebra/matrix-calculator.html. You can use other matrix calculators as well, but this one seems to work pretty well. And the way that matrices work, you need to have the same number of columns over here as you have rows here in order to do a proper calculation. So that means we're going to transpose our coordinates onto this second matrix here rather than the first one. Otherwise, we only have one column, but we have 3 rows. We can't do the calculation. So this way, we have 3 columns and 3 rows. We can do the calculation. So it's 3 by 3, 3 by 1. Now in Blender, I'm just going to delete this cube and add in a mesh, a monkey. And I'm going to go into edit mode of the monkey and just grab one of these coordinates. It really doesn't matter which one I get. So any of them. Push N and I'm going to bring this up here. So this here, negative 0.82, negative 0.44, negative, 0.14, they're my original coordinates for this. So I'll go back into here, negative 0.82, negative 0.44. So I'm going to transpose those into here. So negative 0.82, negative 0.44, and the last one was 0.14, I think. Let's go back and check, 0.15. And that should be 0.45, and that should be 83. So I'll just increase them all. 15, 45, 83. Now I'm going to rotate this around the, I'll just open up the CS field guide. And we've got computer graphics. And I've done it around the X and Y, I think, before plenty of times. So let's try it around the Z and just make sure that it's all good. We'll find that here. So let's see. This is rotating around the Z axis. So I'm going to use this one here. Now I'm just going to do it 45 because I already know the cosine 45 and sine 45 values. So I'm going to go back to here. Where have we got it? It's up here. So cosine 45 is 0.707. Negative sine 45 is negative 0.707. Sine 45 is 0.707. And then cosine 45 is 0.707. That's really easy. And then I just put 1 in the corner here. So this here is the rotate around a Z axis. Now I'm just going to do it in Blender. I'm going to go back into object mode, hit R, hit Z, and type 45. Now if I tab back in, you'll see that these coordinates are the same. It's still got that point selected, but if I hit global, they will have changed. Okay, because these are the global ones. You don't want to use the local coordinates. They won't change at all. That's because, well, I'm not really going to explain that, but you want to use the global ones to find out where it is in relation to the origin. Now, if I go back, this one won't change because we haven't changed the Z-axis. We're rotating it around the Z-axis. So that one shouldn't change. It's always going to be at that same height. I'll go back to matrix calculator and do this AB one, which means A times B. Okay, so the new coordinates for that point should be, according to the matrix, negative 0.26. And it pretty much is up there, negative 0.27. They will be slightly different because I didn't put in the whole thing. Or negative 0.27. See if I round it up. Negative 0.90. Negative 0.90. And 0.15. 0.15 rounded up. Okay, so that's really all you need to do is show that multiplication of a point in 3D around the Z-axis in this case, and then I did it in Blender and showed that these were the new coordinates. Screenshot this stuff. If you don't know how to use snipping tool, it's really easy. Just have a look and you'll figure it out pretty quick. Screenshot the other example, show the matrices. You might have to, you could even draw it on paper if you're having trouble trying to create it on the screen. Just draw it on paper and scan it in or take a photo of it.